All right. Good afternoon, everyone. Thank you so much for joining us. I'm Michelle Schuler. I'm the co-chair of IFMA Boston's Think Tank Committee. I'm going to read a script today. I'm not a script reader, so bear with me as I read through this. But on behalf of the board of directors, I'd like to thank you for joining us for today's webinar on batteries, EV storage, and micromobility. IFMA is the only organization dedicated solely to furthering the profession of facilities management. The chapter's mission is to be the complete expert resource for facilities managers as well as those who support the built environment in the Boston area. We provide a full range of programming throughout the year, including publications, training, webinars, tours, networking, and special events. Please check your email for upcoming events. Now I'd like to introduce today's speaker. Robert Duvall has been a fire investigator for the NFPA, National Fire Protection Association, which is based in Quincy, Massachusetts, since 1997. He's responsible for conducting investigations of technically significant incidents in order to gather lessons learned from each incident and to apply those lessons to improving NFPA codes and standards. The investigation of these incidents includes documenting the emergency service response, the structures involved, as well as the events leading up to and following the incident. Robert was named the New England Regional Manager for NFPA in 2003. As Regional Director, Robert is responsible for outreach within the Northeast states regarding code adoptions and training. He also serves as a point of contact for stakeholders in the NFPA process, including the fire service, engineering, and safety professionals. Robert has served as the chief of the Atwood Hose Fire Company in his hometown of, Robert, you're going to have to correct me, Wagoran, Connecticut?
Warrigan.
Okay, there we go.
You were close.
Thank you. Where he has been a member since 1981. He also serves on the instructional staff of the Eastern Connecticut Fire Training School. And now, after all of that, I'm going to turn it over to Bob.
Thank you, Michelle. Thank you, everyone, for joining us today. This is, pardon the pun, a very hot button topic in the fire service, in facility management, in fire safety and fire protection. And it's not slowing down. The technology is, we all know, technology in our everyday lives is increasing in complexity and ease of use and sometimes complication of use constantly. And we're trying to keep up with this technology is difficult on all facets of fire protection and fire safety. As a matter of fact, this is so important that this was the theme for NFPA's Fire Prevention Week theme this year, which happened a couple of weeks ago. It was charge into fire safety, and it was awareness of charging of batteries, rechargeable battery appliances and devices in the home. So what I'm going to do over the next several slides is, at first, we're going to give you some incidents that have occurred recently in the last couple of years, and we're going to focus early on about New York City because that became the epicenter of a lot of this because of their the micromobility, use of micromobility in the city. And then we're going to transition to EVs for a little bit and talk about parking garages. And then in the end, the third portion of it is battery energy storage systems, just a basic primer on what they are and where they can impact you in your facilities and just in your daily lives. So we always ask, what's the problem? You know, we're using batteries all the time. If I'm doing this in a lecture hall, I count how many people are in there, and then I double it and say that's how many batteries are in here right now. Because if you don't have two phones, you have a laptop or a tablet or some other rechargeable device in your backpack while you're sitting there at the presentation. So we carry these things with us all the time. We don't even think about it most of the time. But there is a propensity for certain devices to fail for various reasons, which we'll talk about in a little bit. This is a nanny cam video that shows a micromobility device failing while the family is sitting in the living room. So that's the device, the battery going into thermal runaway. Dad does the right thing by unplugging it, but it's too late. All right, so that's actual footage. That's not a Steven Spielberg or a James Cameron special effect. And I'll show you more about the size of that battery pack in a couple of slides. This is a surveillance camera or a security footage from a battery manufacturing facility. And watch where that circle is. Watch for the failure in the batteries, and then it'll take you through the news story on what the outcome of this fire was.
Surveillance footage shows the moment a deadly fire started at a South Korean battery manufacturer and killed 23 workers on Monday. The video shows smoke coming from a stack of lithium batteries, and in a factory which contained around 35,000 of them, the fire quickly evolved into a huge blaze which then sparked explosions. The now gutted structure was in Hwaseong, an industrial cluster southwest of the capital, Seoul. Firefighters with search dogs combed the remains on Tuesday and found the body of the last unaccounted for person, raising the death toll to 23.
So 23 people. Now, I don't know anything about the exiting in that building or any fire protection or anything else, but the fact that those fires in these batteries spread so fast that chances are many of those folks did not have a chance to seek an egress stairwell or doorway to get out. But I can't say anything about the design of the building and how it was arranged and egress arrangement and length of exit and travel exit distance and so on. But you saw how rapidly the batteries ignited, and one sets the next one off, which sets the next one off, and you saw the futility of that fire extinguisher. Um, the You'll see in some later slides the best way to extinguish these fires is with water. Um, Gaseous suppression, like a fire extinguisher or a room agent system, is only good if the room is tight and you can smother the fire by eliminating oxygen. So that fire extinguisher on that pile of batteries really didn't do much, as you saw. So, going back to when we first started addressing this around the pandemic and coming out of the pandemic, there was pretty much a news story every day from somewhere in the world about a battery fire or research going on into these battery fires and why they're occurring and so on. So New York City seemed to be the epicenter of this. If you've ever been to New York, if you've ever tried to drive in New York, if you've ever tried to cross the street in New York, you know that the micromobility, which is a fancy word for scooters and e-bikes. Scooters are at one point are probably going to outnumber the cars in some cities because of their ease of travel. You can get around a lot easier on a scooter than you can in an automobile in some of these congested cities. So a lot of folks in New York had purchased these things, and that was how they commuted. That's how they got to school. That's how they did their job, whether it was a courier or DoorDash, Grubhub type of thing, and that's how they get around. And at the end of the day, they would bring these scooters into their apartments, into their condos, into their place, and plug them in. Now, not all of these scooters are top shelf, high end equipment. They're often hand me downs and or less than stellar quality devices, and they were causing fires on a rapid rate. So in 2021, the first time they gathered numbers in New York City, they found 104 fires were initiated by these batteries, 79 injuries and 4 deaths. But that was hand picking the numbers because there wasn't a way to pull lithium ion battery fires out of their fire reporting. It wasn't a drop down box that they could check. So they had to go into all of these fires and look for a narrative that said there was a battery powered device or something in the apartment or in the building. So in 2022, it was up to 216 fires, 147 deaths, 147 injuries and 6 deaths. 2023, the number continues to climb. Um, and it was a 200% increase and 21% increase in injuries and 2% increasing 2% in the city over the year. So they started to put messaging out. We're going to jump to 2024. I'm sorry. 2024, 6 fatalities. So it was a two-pronged approach. They got some PSAs on local television, and then the fire marshals got out and started finding these bike shops, which 10 years ago sold pedal bikes. Now the and they were going in to inspect them to make sure that the batteries were stored properly. They were using listed batteries and not what they call Frankenstein batteries, which I'll talk about in just a little bit, and so on and so forth. And eventually, there was a local ordinance that was passed in which the fire marshals could arrest the proprietors of these shops if they weren't doing everything up to code. But we'll get to that in just a little bit. So you may or may not have seen this fire in the news several years ago in New York. I think it was in 2022. High-rise apartment complex at 2022. The fire department had to do multiple rope rescues, which is extremely unusual.
Fire, EMS, and dispatch did an extraordinary job rescuing a number of civilians, including an incredible roof rope rescue that many of you have seen on the 20th floor.
There was an e-bike that ran away in the living room, and those people were driven to the bedrooms, which is the windows that you see here. If you look to the right, you see the fire department is making entry into the living room with a hose line, but these people were driven into this room, and you saw the amount of smoke here as the firefighters are taking them to a floor below the fire to take them out of the building safely. Everyone was rescued. There were no fatalities here. There was some serious injuries, smoke inhalation mostly.
Resort in the FDNY, we rescued 2 civilians from the fire department. It's what we saw today was our training, our teamwork, and our absolute dedication.
The woman they're rescuing here is stuck on a child. This down. So that was attributed to a lithium-ion battery in the living room that was charging, that caught fire and drove those people to the last resort to wait for rescue in the bedroom of that apartment. So in September of that year, the fire department hosted a battery symposium. As part of it, they had lectures from experts at UL and some other research facilities and the fire department on what they had found and what they were researching on lithium-ion batteries. So part of that was also a lot of hands-on demonstrations. So you remember that first video I showed you, that battery that ran away on the scooter. What I'm going to show you here is a scooter battery in a Connex box with some metal mesh over the front, running away. They drove it to thermal runaway by overcharging it and putting it on a hot plate. So they overcharged it while making it really hot and drove it to failure. And this is what it looks like when a battery in a scooter fails. So each one of those projectiles is a battery cell, a little bit bigger than a AA battery. And when it vents, when it overheats, there's a vent built into it. And when it vents, it launches. So if the case has been compromised, it'll launch outside the case. So you saw there, if that wasn't in a Connex box, there would have been multiple little fires set all over the apartment had this failed. So depending on the size of the battery, it also determines the number of cells. And we'll talk about cell and battery pack architecture in just a little bit. All right. So in September of 23, the city passed a law which gave some teeth to selling and using only listed batteries and not something that comes from some country where there's no quality control and it slides in, unbeknownst to anyone. They implored the online retailers to sell only listed material and not some junk that hadn't been tested. And now they had some teeth so they could go in and issue violations. And all the UL standards that these batteries are tested to are listed in that ordinance. So they have something to look at and say, well, this isn't UL listed. It wasn't tested to a UL standard. And they made several arrests and filed several violation notices to some of these folks that were selling stuff out the back door, whether it was a reconstituted battery or a Frankenstein battery, or if it was something they were buying on the cheap, adding a couple of dollars to it, and then selling it out the door, even though it wasn't listed. But as that was going on, fires continued in the city. This was in November of 2023. 3 people were killed. There was lithium-ion batteries in the apartment that you see on fire here. This is on arrival of the fire department. This is how fast these fires spread. In New York, their response time is usually 3 to 4 minutes. And you can imagine somebody makes a phone call, 3 to 4 minutes later, there were fire apparatus in front of the building. This is what they were faced with. This is how fast these fires spread. So this is some of the arrests that they made starting in February of 2024. And the fire marshals made a big deal out of the first couple of arrests that they made. They called the media and they did a perp walk of the person out of the shop to kind of get everyone's attention that if you owned a bike shop, you might want to clean up your act. Your friend down the street just got arrested and he was on the 6 o'clock news as the marshals walked him into their car and brought him down to the police precinct and booked him. They found 60 battery packs in the back of the shop, all of them either not listed or reconstituted. He took a soldering iron and he was making batteries out of old batteries and resoldering them, putting some duct tape around them and putting them back into scooters. This was another one in 2024 in Brooklyn. They look great, right? Nice shiny black cases there, but if you look at them, there's no labels on them. He's basically prying open the case, testing the batteries, putting batteries from old batteries in here, soldering them, closing the case up, and putting it on a scooter and selling it. The problem is not only US based. These were 2 incidents in late 2024 and early 25 in England, caused by e-bikes in residential properties that caused some serious damage. And 3 people died since 2023 in England in fires that were attributed to lithium batteries. So this is one of the PSAs that FDNY put out, and they have been pretty effective. What they found, one of the biggest problems was people were storing these things and charging them in their homes. Now, a lot of places, there's no garage, there's no basement, there's no backyard, there's no little tool shed. So they have to do this. So they were telling them, listen, charge it until it's full and then unplug it. Don't put it by your front door, because if it does go into runaway, you're not going to be able to use that door to get out, and so on. So a lot of safety related messaging, and they've attributed that to the number of injuries and fatalities, not necessarily the number of fires. It's going to be hard to slow that trend down, but the number of injuries and fatalities, people are heeding this messaging. So the next slide shows you that it's not only people that we have to concern ourselves with, it's our pets. This dog, who happened to be the pet of a firefighter, or a fire marshal actually, in North Carolina, decided to make a toy out of a battery pack. And
it was a near miss for this 5-year-old rescue, Colton. His owner shared this video with us, moments after he grabbed a lithium-ion battery-powered device, broke the safety seal, and chewed up the battery, leading to this.
He bit into it, and you can see it, he's surprised by it, and then he's like, uh-oh, what did I do?
Sasser, who's a firefighter himself, says the fire was out within minutes.
Thankfully, it pretty much fizzled out because of the rug and because we were home so quick. So
is the rug still over there?
Oh no, that was the only thing we lost.
WREL has reported on the dangers of these batteries before. While they're safe to use, they can spark fires if not taken care of.
When you're done charging them, like, you have to really pay attention and unplug them. You have to make sure you store them, where they can't get broken or cracked or chewed on by a dog. And then when you're done with them, they have to be disposed in a specific way.
In Raleigh, lithium batteries have been linked to about a dozen fires in the past year. And in Durham, 2 trash trucks caught on fire after batteries were thrown away instead of recycled. For Sasser, it's a reminder to use his platform to let people know how to use them safely. And thankfully, Colton is okay.
So the trash truck angle I'm going to cover in a little bit as well. But it's just another thing to worry about. Dogs will chew on things, and they don't know any better. And if these battery packs are damaged in any way, that's what leads to thermal runaway in many cases. And Colton is not the first dog to have caused a problem. There's another video that I use in the long form of this presentation, where a couple of dogs chew on a battery pack, and then the cat walks in the room going, oh, see ya, you guys are up to no good. The cat leaves and shows the 2 dogs how to get out of the house. All 3 pets survived, but the house was severely damaged. There is federal legislation on multiple levels once the government gets back to work, apparently, on listing and a lot of the safety features that we talked about in the New York City legislation. And I know a lot of states are also working on local legislation at the state level that anything sold in their state has to be listed, tested, et cetera, et cetera. And they are working on it, putting the Consumer Product Safety Commission in charge of it at the federal level. Airplanes, anyone that's traveled in the last couple of months, you notice that they've added a couple of safety messages, both at the gate and then once you get on the plane, about battery banks, battery chargers, and things like that. They'll ask you on your carry-on, do you have anything in your carry-on, a battery charger or battery bank? Remember the person that invented the luggage that had the battery bank in them so you could charge your devices while you were traveling? Well, now they're asking you about that, and in many cases you have to unplug that battery before you go on the plane. So they are asking about these things. There's been several noted cases of batteries catching fire on planes. This was a big one earlier this year that burned the roof right off of a plane while it was at the gate, thankfully, in South Korea, and it was attributed to a battery, a portable battery stored in baggage in the overhead luggage compartment on the plane. I'm going to skip over that one. Another thing about batteries being stored in apartment buildings and such, this video is from China. Fire starts in the apartment, spreads to an area where batteries were stored illegally.
This is the horrifying moment an explosion from a high-rise residential building in China left the tower engulfed in flames.
From the street. We'll skip the narration. It's a little over dramatic. But I wanted to show that those batteries were stored in a storage room in that apartment building illegally. So where are these batteries used? We talked about it in the early part. They're pretty much everywhere now. We have them on our person all the time, in a purse or on your belt or in your pocket. You're using them in your laptops, in your tablets, tools. If you use, who still uses corded tools? Everything is cordless now. So you just slap a fresh battery on and go do your project. And construction sites, you'll see large banks of battery chargers, and the craftsmen will come and go, get a charged battery, go back out to their place and drill and saw and all kinds of other things while they're on the job site. They're coming to your home in the form of battery energy storage for 1 and 2 family dwellings. Where you can put it on a wall of your garage or in a position where when you lose power or you're at a high peak area, you can shave some power from the grid and use the batteries. Or if you do lose power in your building, it'll pick up the ball and run with it like a generator would. The chemistry, we use lithium ion as kind of that catch-all, but there's a lithium family that has lithium and other chemistries within, and it's all based on what the tool or device is going to be used for and the power density needed. You don't need much power density in a cell phone to run that little processor in your phone, but if you're moving a car or a micromobility device, you need much more density in the power. So the lithium family is the chemistry is based on what the object is going to be used for. So what makes these batteries fail? So the batteries are designed very simply with a positive electrode and a negative electrode. One's an anode and one's a cathode. and a small separator. When I say small, I'm talking 1/1000th of an inch film between those two. And as long as those two things are fine and they go about their business and the electrons pass back and forth and create the power. If the positive and the negative electrode come in contact with one another is when the heat starts to get generated. It creates the short circuit and leads to runaway. A very small battery, like a button battery in your watch or in some small device, if that happens when it gets crushed or something, there's not much there to cause a problem. It's going to smoke. You might get a little bit of flame, and then it's going to go out. Now take that and multiply it by the size of the battery in the scooter, the e-bike, a car, et cetera, et cetera. So the larger the battery, the more power in the batteries, the more likely there's going to be a larger incident when the positive and negative come together. So these things come in various formats. You see the coin batteries I talked about, cylindrical. Pouch is probably what's in your laptop and maybe a small version in a phone. Prismatic starts to look more like a car battery or a small tractor battery that we're accustomed to. And they come in various shapes and sizes and various configurations. When we get into automobiles, it's still kind of the same. It's all based on the battery pack of that manufacturer. They all have their own specific means of manufacturing. Up until a while ago, Tesla used only cylindrical batteries, just hundreds and hundreds of them in their battery packs. Now they've kind of changed. There's a little bit of both. So if you see the inside of a battery pack on an EV, you could see thousands of cylinders, or you could see pouches or prismatic shaped batteries within the pack. It's all based on the manufacturer's design. So this goes into the watt hours or the density of that power, and you know this kind of makes sense. You don't need a lot of power for your phone. You need a lot for the scooter, and you need a lot more for the battery energy storage, or an electric vehicle is kind of thrown in there for comparison. Or if you've got a utility scale ESS, you're talking 2,000 kilowatt hours for power within those batteries. So the problem is we don't know what we don't know about a lot of these things. Research is going on constantly, but at the same time, they're changing the chemistry in these batteries to try to make them better and last longer and be more powerful. So just as soon as we get our hands around, say like lead acid technology, which is old school batteries, we've moved on to lithium, and we're moving on to sodium, and we're moving on to other things. So that's a lot of the issue. We're chasing our tail when it comes to the safety part of these things, because research goes so far, and then they come out with something new, and we've got to research it all over again, or take their research and verify it. Thermal runaway we've talked about. Even if though you put them out, they have the ability to reignite. The heat will be generated within the battery pack, and it may come back to life and burn again. We see this a lot in EVs. You put the fire out, or after an accident, there's no fire, but they tow it to a recovery yard, and it catches fire 2 days later in the recovery yard. This stuff is extremely toxic because of the chemistry that's being used in there. When it off gases, it might not catch fire, but it will off gas. That gas is extremely dangerous to bystanders and the fire service. The breathing apparatus is 110% required anytime you're dealing with these things from the fire service. And then decontaminating your equipment and your PPE is very important after fighting one of these fires as well. Stranded energy is a phrase for what's left in the battery when it catches fire. The battery's at 100% when it catches fire. It's going to last. That event is going to last longer until all of that energy is expended, or you cool it down to the point where it's no longer being expended. If the battery only has 10% in it, it's not going to be as violent an event, because the energy is going to be dissipated rather quickly. Again, take that to the EV example. If you just charge the car and you're driving down the road for a few minutes and something happens, you've got 100% charge on that battery. It's going to take a while to get that battery below where it's going to be into thermal runaway. There is an explosion potential, especially when you collect the gas that's off gas from these things, and we'll talk about that a little bit. And then user error is probably 90% of the problem here, is people don't charge these things and maintain them properly. quick little graphic on what thermal runaway looks like in a batch of cylinders. You have one battery cell that goes bad or gets damaged, and then it spreads to others, just like a grass fire. You have one small patch of grass that catches fire, and next thing you know, there's an acre burning because it just heats the stuff around it and just spreads rapidly. Here's a thermal image of a battery pack, very small one. One cylinder is being driven to runaway, and you see it's going to spread rapidly to those other 4 or 5 pretty quickly afterwards. So the failure modes, don't try this at home. This is just to make a point. Thermal abuse, if anyone's ever taken a tablet out on a warm day, and you tried to use it and all of a sudden it shuts down manually and it tells you it's too warm, that's battery management sensing that battery is too hot, and it will fail shortly if you don't shut it down. And it may even tell you to take it out of the heated area, maybe put it in a cooler area. That's battery management. Some of these things don't have that built into them because it's just not that fancy of a battery. You leave it on the dashboard of your car on a hot day, or you put it next to a heat source, it will overheat and possibly go into failure. Mechanical abuse is what you see here, driving over it with a forklift, having it penetrated by a sharp object. If you're up on a ladder doing a project and you drop a cordless tool down on the sidewalk and it lands just right, I would highly suggest you take that battery and recycle it. Kind of put it over to the side for a little while, see if it does anything, and then take it back to where you purchased it. A lot of the big box stores will allow you to recycle the battery because they want you to buy another one when one is expended. So use that as an option if you do have a cordless tool, and you check with your big box store or hardware shop in your neighborhood and say, hey, can I bring this back and recycle it? Don't bring it back smoking in a pail of water. That's not going to work. They won't take it back then. But if you say, hey, I want to buy another one to replace this one, can I recycle this? Electrical abuse, overcharging, charging too fast, discharging too fast. I use the example, if you go to a convenience store, right next to the lottery tickets is often a little kiosk for charging cables because everybody's forgetting their charging cables or they damage them somehow. Are you matching up the charging cable and the charging rate of that cable with the device you're plugging it into? Chances are you're not. You're just saying, oh, it fits. The adapter fits, and you charge it. If the device you're charging all of a sudden gets really warm and it never got warm in the past, you're overcharging it, and that cord is probably not right for that device you're charging. Internal faults, quality of manufacturing, that's about the only thing you can attribute that. And then other things, if it's in an area where it gets flooded, there's an earthquake, you got rodent damage to wiring that may cause a short circuit of some kind, and extreme heat, if it's in a spot where it's exposed to heat for extended periods of time. We've kind of talked about this one already. And then there's one other means of doing failure, but what this is over time. This is an age thing where in the anode, you get these little things called dendrites. It looks like stalactites or stalagmites in a cave, and they get sharp little edges on them, and they will penetrate the separator, and that creates the short circuit. So this is more of a age-related issue with the batteries. Not that you can see that by looking at the battery yourself. Again, this is kind of a reminder. So this last video, we'll get off of scooters, but this was from the UL labs, and the upper one where it says bedroom 1 low, there's a scooter. They're overcharging it in a mock apartment with a bedroom. So this would be the scenario would be someone comes home from work, the scooter's at 30%, they plug it in, they got to go back to work in 8 hours, they're going to rapid charge it, they lay down for a nap in that bedroom, and this is going to be what happens. I want you to look at the infrared, look at the temperature on the infrared, and the scooter is actually there. You can't quite see it through the gray, but you'll be able to start to see heated gases coming off of the scooter. You can't see them in the camera version right now. Now you can see them, but this is sped up time. But it's 52 degrees Fahrenheit in that apartment. And now that scooter's going to run away. Hopefully the person wakes up and is able to get out of that bedroom. But if they don't, this is what's going to happen. And the temperature goes to 1,155 degrees in like 3 seconds. You saw it blew the window out of the bedroom, and it destroyed the camera at the high level in that bedroom. just in a matter of, they charged it for an hour and 43 minutes. So that's a pretty good long nap, but that person probably wouldn't have gotten out of that bedroom. Those of you that do apartment buildings and condo complexes, you'd appreciate this. In New York, they kept telling folks, please don't charge your devices inside your apartments. So some landlords thought they were doing the right thing, and they built areas where they would allow the folks to charge their battery packs. The FDNY inspectors found this in the basement of a 34-story building in Manhattan, where they had made multiple cubbies and allowed people to put their batteries in there. Now you see in the middle and the far right picture, all they did was daisy chain plug strips into a 4-box electrical outlet box on the wall. So there were however many, 7 by 8, probably 50 to 60 of those cubbies, all being powered off of one 4 outlet box.
Combustible too.
Yes, and
Combustible box.
they made it out of wood. They made it out of wood. So needless to say, the marshals shut this down immediately and said, you can't do that. But the guy thought he was doing the right thing, but he really didn't think it through. Massachusetts Fire Marshal's Office has a questionnaire for fire departments. If they have a battery fire, they fill out this questionnaire and get it back to the Mass Fire Marshal's Office. And these are the latest through October, the end of October. 22 laptops, 49 micromobilities, 28 cell phones, 30 tools, 36 battery chargers for a total of 237 fires, all being slated as the cause of the fire. Now, this is voluntary, so the fire departments have to think to fill this out and get it back in. So it's by no means all encompassing, but that's been going on for about 2 years now. So there's 240 fires in the Commonwealth, including this fire from Onset. This is a hobby shop. You see the battery fail going to runaway on that table. You see a person in the background here between the two emblems. He's exiting. He's probably the one that called 911. And this takes you through the video, and then you'll see the end result. Fire department arrived relatively quickly and put the fire down in the shop before it spread to the actual building, but that's the end result. So the shop is gutted. They have to completely redo the inside of that shop. So I left these with Geo. There's a handout available with all of these QR codes, so don't scramble for your phone to try to get the QR code on your phone before we move on. All NFPA resources on micromobility and lithium batteries, including a way to download these 2 sheets here, which are safety bulletins from the NFPA on lithium ion in general, and then e-bikes and e-scooter safety. So moving on to EV fires, these are in the news quite frequently because they're spectacular when they happen, and it's because it's new and unique. You don't see a car fire, an internal combustion fire, on the news every night because they're very common. They happen quite a bit, usually at rush hour, and screw everything up, right? EV fires happen a lot less because there's a lot fewer EVs on the road. However, when they happen, they usually result in some extended delays, and fire department has to spend some extended time extinguishing it and overhauling it and so on and so forth. But EVs have been around for a while. This is an older model from, the Model T age where they say, oh, maybe we shouldn't use gasoline. Maybe we should use batteries. But of course, the technology back then wasn't what it is now. And they probably got 2 miles out of this charge versus however many miles on the tank of gas. But now it's become very common technology. You see quite a few of them on the road while you're driving. You look around, you can see them all, surrounding you in traffic. They're all designed differently. The manufacturers use their design features differently, but for the most part, most of the batteries sit kind of low in the car for center of gravity, for handling purposes. But how the battery is shaped and how it interacts with the vehicle is a 4-hour presentation on itself. But know that the batteries are shielded inside the car. They're not easily accessed, which makes the fire department crazy at times, trying to put these things out. But for the most part, this is where they reside. This is a film from a parking garage surveillance camera. This is what one of these vehicles looks like when it goes to runaway. That wasn't sped up. That was the rate at which that failed. So you don't really have a warning in many cases. You may be able to smell something. You may see some deformity, but in some cases it may happen as you walk away. You walk to the elevator to go to work or go to the building you're in, and this may happen just as soon as the elevator doors close. So again, the battery pack construction, we talked about that in an earlier slide, and they just pile battery upon battery upon battery, put them in series or parallel, and make them operate the vehicle. So when the vehicle catches fire, the fire department's got a few options. Water is their best option. Multiple hose streams if they can apply them. And again, you have to cool these batteries. You're not getting to the actual cells immediately, if at all, because of the way they're buried inside the car. So in this case, they would apply hose streams. You have devices that will, you hook the hose up to and slide under the vehicle, and it cools the battery pack underneath the vehicle. And then you have blankets, which are sold to put over the car, especially in a parking garage or an area where there are other cars around them. They're good for when there's exposures. However, in research that NFPA conducted, they found that if the blankets are not applied properly or moved in some point during the process, they may cause a gas explosion. The gas builds up under the blanket. If you open the blanket and let some fresh air in there, and the equation may get to the point where it's not too rich, it's not too lean, it's just perfect, and there may be an explosion, pressure release of the gas. We have a report that's coming out in the very near future that shows a lot of that occurred during the testing. Some agencies have said, that's it, we're not using the blankets anymore. And others have said, just be very careful when you do them and don't expose your firefighters and bystanders to that, should that explosion potential exist. So identification of the vehicles, it's difficult in a vehicle that doesn't start with a T, because all of those are electric vehicles, but all of the other big manufacturers have hybrids. They have gasoline or diesel powered, and then all electric vehicles. So they're difficult to identify in some cases. From the fire service, we're constantly, looking to make sure if we're pulling up to an accident or an automobile fire, is it electric or is it internal combustion? And then we act appropriately. In parking garages, you can just go down a whole row and kind of point and say, well, that's an EV, that's a hybrid, that's gasoline, that's EV, and so on. It's difficult because there's no standard badging for the manufacturers to do. There's not a big E on the hood that can tell everyone that that's an electric vehicle. So here's a video from a parking garage. I wanted to show folks this for those of you that have parking garages in your facilities. This is from the Czech Republic in Prague. This is their fire brigade battling an electric car, an EV fire in a below grade parking garage. So you see the amount of smoke probably coming up the ramp from the garage. So now they're putting their personal protective clothing on, and they're entering the garage. You'll see them in a second battling the fire, which is pretty much out by the time the cameraman gets downstairs. So what they're bringing down there is a high pressure lance. There it is right there. Using tremendous pressure, they're going to open up the floor of the car to apply water to the battery. We'll see in just a second. He's using it now. That's the hose that goes over the shoulder right there of that firefighter. He's cutting a hole in the floor to expose the battery, and then they applied water to the battery pack, and it was quite effective in this case. You notice that there's only smoke now. There's no more fire. They're applying water underneath. They've lifted the vehicle to get water underneath the vehicle. And then once it's finished, they're going to remove the vehicle from the parking garage. Pardon, my fire department's got a call. That's that noise in the background. So now you see they're putting dollies. They're putting dollies on the car, and you're going to remove the car from the parking garage by using an elevator, I wouldn't recommend it, but if that's the only option, that's what they're going to have to do. Now they're going to push the vehicle out of the way. I'm guessing they moved the other vehicles around it. No. Now, keep in mind, not every fire department has these things available to them, the dollies and things. Maybe the parking garage provided those for moving vehicles that have stalled and are unable to move. But now they're going to place this into the elevator and bring it upstairs. So there's a happy ending. Everybody came out fine. They winched the vehicle out of the elevator. And then you're going to see they're going to put it in a dumpster-looking device. And that's in case the vehicle catches fire again on the way to the recovery yard. They can flood that dumpster and quell the fire. But this is an accepted way of transporting these vehicles in Europe. Hasn't really caught on in the United States in many places. I haven't seen any on the East Coast yet. I understand there may be some on the highway system in California, but nothing on in our neck of the woods yet. But coming soon. They make them specifically for that case. You see there's some fittings on the side where you can put water into the dumpster. Some of them come with an option for a crane. You're going to see they pick it up with the flatbed, the low bed here, and then drop the vehicle into it, and they can flood the dumpster full of water. Again, it hasn't caught on much in the United States, but is being used in other parts of the world. In August of 2024, there was a fire in a parking garage in South Korea that resulted in serious damage to both the building and the parking garage. You can see it's what started in an EV spread to any car around it. And they had to reevaluate and run an engineering study on the floor of the parking garage to see if there was any damage that required shoring or redesign or repouring of the concrete, replacing of the concrete. In Spain, 2 firefighters were killed in a parking garage fire involving an EV. We'll skip over the video for the sake of time, but they were approaching the vehicle that was on fire and it vented and killed one firefighter instantly. And then the other firefighter's breathing apparatus was knocked off and he breathed in enough smoke where he became ill and eventually perished.
Bob, quick question. It's Andrew. Yep. This is probably one of my biggest fears, knowing that it's in a corporate environment, it's below grade, you have EV. Any recommendations? I know you could probably do like emergency response with the fire department or even consider doing a capital project. I'm not sure if it adds value, just kind of dense populating sprinkler protection, just copious amounts of water to prevent it from spreading. Again, as you mentioned, you're not really putting it out, you're just trying to contain it at that point until it, I guess, burns
until it puts itself out, right?
Yeah.
There's a research project on that. I'm going to talk about it in just a second, but sprinklers are your best bet, but they're not always an option in some parking garage designs because it may be a dry system, which is okay, but there's a delay in getting water to the fire because the air has to be exhausted from the system before the water comes. But yes, that's your best option because the fire department's going to arrive, but it's going to take a bit for them to access where the fire is through standpipes and other things. So if the sprinklers are available and controlling the fire department it buys them some time to access safely. And, if there's anyone in the parking garage that they have to rescue and show, to a safe avenue, staircase or what have you, that allows them to do that as well as access the fire and finish extinguishing the fire.
Awesome. Thank you.
This was a fire in 2017, 1,600 car capacity, 1,400 of them were damaged. There were no sprinklers in this parking garage, and they had to tear the garage down. You see the spalling in the concrete in that lower picture. So we've done, we being NFPA's Research Foundation, has done several research projects involving electric vehicles, including parking garages. Those research reports are all available online on our website for free of charge to download. So you can kind of see what the state of the art in protection requirements and recommendations are. And a lot of this research goes into the next edition of the codes. They take this research and say, research has shown, yes, that you put sprinklers in this density, in this type of environment, it will control the fire and so on. So there is a lot of detail out there that's available for review and for sharing with your engineering firms that you may be working with on designing and architects, etc., and also with the fire department. The next several slides we'll go through quickly because it's on the fire service side, but water is still your best bet. We're not asking fire departments to go out and spend millions of dollars on exotic chemicals that may or may not work on EV fires. There's additives that people are out selling that may encapsulate the battery once they spray it on there, but water is still by far the best agent for that. I mentioned respiratory hazards. These batteries, when they burn, are extremely toxic, and we're warning the fire service. Wear breathing apparatus when in the vicinity of these batteries when they're burning. Don't get upwind so you get the plume of smoke, and make sure you decon properly when you're finished with the fire. So that's what all of that is. This report here is due out shortly. This gives the fire service some tactics which to fight EV fires and the impact that stranded energy in the batteries have on these fires. So this report, look for this report be coming out in the next couple of weeks. They're putting the final polishing on it. They did a webinar on it that'll be available on our website this week, on it last week, covering the highlights of the report. And the fire service is eagerly awaiting this when it comes out. Somebody sent this to me. This is not an option that you can get on a EV to help get water to the battery, but it's out there on the internet. What would we do without Instagram, I guess? This is a battery recycling facility in Missouri that caught fire and reportedly had a state-of-the-art extinguishing system within. I'd question that, considering the building is a total loss. We talked about trash truck fires. People are not properly disposing of these batteries. They're throwing them in the trash. And what happens is the trash trucks, when they compact the trash to put more trash in, or you go to a facility like this and they shred it, you'll see a fire start on here shortly in the shredder, because that's how you damage these batteries. You puncture them in a shredder and the battery catches fire. This next video is, it's a short clip from a recycling facility, and it's not going to let me play. Well, anyway, you see that truck that pulls away? There he goes. Truck pulls away, and you'll see a small fire on the pile behind him, and it's already started, probably from the load previous to that one. And then people are aware of it. They bring every fire extinguisher in a 2-mile radius to try to put it out. The guy in the payloader is the hero. He separated it from everything else. No one's wearing breathing apparatus in this picture because they're all just workers in the recycling plant, but they're exposing themselves to extreme amounts of toxic vapor. But they did separate it from the rest of the pile and probably made things a lot easier on the fire department when they arrived. We have battery-powered construction equipment now. You may or may not see that in your facilities as during construction or renovation. It's not just the small little mini excavators. It's large pieces of equipment are battery-powered now. So look for that. Look for how they charge them on your sites when they come out. But it is becoming a fact of life. This is a recent incident in a facility in Hopkinton that tests batteries. And they had a battery go into runaway in the building, and the fire alarm went off. The fire department showed up to a well-involved compartment within the lab where batteries were burning inside the building. EV charging stations are another thing, especially in parking garages. There's several code requirements, both in the National Electrical Code and in the our parking garage standard, on how these things need to be designed. Again, this is another presentation all in itself. I would suggest that if you have them being proposed or you already have them in your facilities, you check to make sure that what version of the NEC they were designed to, and make sure that everything is up to standard as far as the electrical devices within the installation. So last but not least, I know I only have a few minutes. I'm probably going to go over a little bit, but battery energy storage systems on the utility size level. This was a facility in Arizona in 2019, just before our standard on battery energy storage came out. The fire department wasn't aware that it was out there. They got a call for smoke in the area. So they thought it may have been a brush fire, considering how remote it was. They showed up and saw the smoke was coming from this unit. So they upgraded the response to a hazmat. The utility representative showed up and wasn't able to tell them a whole lot about what was going on in there. So they did some research for 3 hours. They metered all around the installation. There was air conditioning, but not proper ventilation inside this installation. And I'm pretty sure the air conditioner shut off when the gaseous suppression system activated inside the energy storage. So they made the decision. You see the door in the center of that picture. They made the decision to open the door and see with a thermal imaging camera what was going on inside the enclosure. They had absolutely no plans to go in the enclosure. They just wanted to see what conditions were inside, because they were getting all kinds of nasty readings on their hazmat meters outside, including cyanide. So when they did open that, the fire officer on the front with the thermal camera said the last thing he remembers is seeing a small red dot on his screen of the thermal imaging camera of a hot spot inside the enclosure. And then the next thing he remembers, he woke up 50 or 60 feet from the enclosure in scrub brush. He had been blown back by the force of the explosion. 8 firefighters were injured, 4 seriously enough to be flown to local trauma centers. There were multiple investigations, which I'll cover briefly in the next couple of slides, that found that there was a thermal runaway in the batteries inside the enclosure that led to the gaseous suppression system to go off based on heat. And once that went off, it only slowed the process down. The thing continued to burn inside that enclosure, and then the atmosphere in there got too rich. But when the fire department opened the door to further investigate, enough fresh air came in that created an explosive atmosphere, which exploded and injured the firefighters. So this is the enclosure. That was the door they used to go in. You can see that the whole thing is off kilter now due to the pressure of the explosion. Also, we don't have time to go over that media account, but there were several reports that were done by the utility and by Underwriters Labs, UL. I went out and met with the fire department and the responders to make sure that our standard 855 had enough items in it that would have prevented this in the future. This enclosure was not built to that standard because that standard wasn't out there at the time of the incident. So I mentioned 855. I'll just get to that now. Let's see. Here we go. This is the latest edition. It just came out about a month ago. This is the 3rd version of this document, and it's the standard for installation of stationary energy storage systems. So if there is one installed in one of your facilities or being proposed in one of your facilities, it should mention 855 somewhere in the plans. This is from cradle to grave when it comes to a BESS. So from the design and construction, installation, the commissioning, the operation, the ITM while it's in place, and then the decommissioning after the fact. I think that was that previous slide. So these things have a life. You plan them, you install them, they serve their purpose, and then they get decommissioned either without a failure or after a battery failure. So with the 2026 edition out, the next several slides I'm gonna just cover very quickly. There's several changes in the document. It basically additions to the standard based on new chemistries that are out there and new technology that's out there. So again, I'm not going to cover all of these. This is an hour-long presentation in itself. But some of the things that you should know as facility managers is there's a requirement for an emergency response plan, which is either the utilities and your responsibility in a partnership, but you also should involve the first responders, the fire departments, and the marshals and the inspectors that are going to be part of this process. It's a requirement. The utility should train you on that if they install it, or if it's a standalone and you own it, the installer and the manufacturer should give you everything you need and possibly walk you through training in person, so your staff knows what to do in the case that something happens with this with these devices. All right, so here's the same slide, just in a kind of a different format. Let's see, there's one or two others I just want to cover here. I mentioned 1 and 2 family dwellings. These are showing up in some some developments. They'll make it an option. You want to have a ESS in your house. It replaces a propane or a diesel generator or a gasoline generator. So they're becoming more and more popular. You'll find them on the walls in garages and such. And they have an automatic transfer switch, just like a generator. So when you lose power, you go over onto battery power. Much quieter, much cleaner. They're a little more expensive than going down to Lowe's and buying a generator and wheeling it into your garage. But the technology has come to the point where it's cost effective to be putting into new buildings and renovations.
Bob, I don't know if how much more you have, but it might be great if we can maybe take some questions, or I don't know if you had
on the last couple slides. Yep.
Okay.
And then we can do that. So the emergency planning I mentioned, it involves everyone that's going to be the installer right on through your facilities people and the fire department. 855 is referenced in NFPA 1, which is the fire code for the Commonwealth of Massachusetts. It's also referenced, and you can get to it in the National Electrical Code. So the utility will provide training for you if it's a utility-based thing. And the last couple slides are all in that handout that I gave Gio. So I'm just going to kind of cover through them real quickly. And we got to the questions. So I don't know how you want to do that, Gio. If you want to read them, or do you want folks to come online and
I think
ask?
People can just, if you stop sharing, people can just
okay, I want to put one more up. This is my contact information. But that slide is also included in the handout material.
Perfect. Okay? I was going to say, I will include that when I send everything out for people.
And for the record, that picture was taken last weekend. If anybody asks.
All right.
I've stopped sharing.
Thank you, Bob. I appreciate it. And thank you for all the information. I saw that Dan had his hand up. Dan.
Yeah. A great presentation. That was really interesting.
Thank you.
So on cleaning PPE, what are your recommendations there?
Well, they've done some research, and the standard extractors get about 60% of the contaminants out. So if you only have access to an industrial extractor, which is a very heavy duty washing machine, they recommend that you run it through the cycle several times.
Okay.
There's really no way in the field to check for contamination. It's, you have to go to a lab and have to take samples and such. So it's basically, when it looks clean, put it in there one more time. And they sell some very high tech extractor equipment, which uses it's not liquid nitrogen. It's a liquid. It's a gaseous agent liquefied, and this equipment costs $1 million.
Yeah.
So only the bigger cities are going to purchase them, or you can do it through regional grants and things like that. But it is that's up to 90% cleaning, but it's extremely expensive technology, unfortunately.
So there's some of these. There's like ozone systems and technologies like that are coming out there that are pretty effective in cleaning some of the toxins and PPE.
And the end game is you want to have it tested after you buy the equipment, or you're going to test it, see if you can do a test drive put some contaminated stuff in there, wash it, and then take it to a lab and get a sample, or the contractors that are doing it in the field, they'll give you a sample. They'll take a reading, or they'll draw something off of the fabric, and they'll tell you how clean it is, and whether it needs to go back into the extractor or the device again, or whether you're good to go. And then when you're confident in the equipment, then I'd say, yeah, go with that technology. But not everybody can afford $1 million washing machine, unfortunately.
Some of these, the ozone ones are like 10,000 or something like that.
So that's kind of in the middle. The extractors are around $3,000 to $4,000 in just the washing machine version, and then you have a dryer that goes along with it, or you can just air dry it or run air through it. Those are the ones that are being sold retail to fire service, fire departments, and contractors that'll do it. The ozone ones, and then the other liquid, I want to say liquid nitrogen, but I don't think it is. I think it was something else. It's escaping me now.
So you say in the field, Bob, that on site at a fire that they're using?
No, they'll take it back to the headquarters.
Fire department.
Yeah, they'll go back to the station. So in many departments, they'll have an extractor in each station. Others contract with a contractor that comes by with a truck that has extractors on board, or they'll take them back to a central location. For example, there's some European departments that collect the gear at the end of the shift. While you go home, they take your gear and wash it, test it, sew any issues that may, any of the reflective striping or any holes that you may have in it, and then get it back to you for when your shift starts the next time. It's sitting in front of your locker in a bag. That's the extreme version, but that's what's being done out in the field.
Okay.
Any other questions?
Yeah, this is Andrew again. Great presentation, Bob. Thank you.
Thank you.
Just a question. I'm not sure what others have, but I have a pretty strict policy because workplace safety is what we do. So we have a bike rack. We'll allow them to come in the building, but strict policy on not charging the e-bikes or scooters.
Mm-hmm.
There's you would think workplace safety takes precedence over workplace experience. However, I know it's probably only a matter of time where someone's going to push for charging. Would it be recommended to say build out not necessarily an explosion-proof room or like a fire-rated compartment where if e-bikes wanted to go in there, would be like contained? It's probably still too early, but just any insights that you've seen so far that's maybe best practice to date?
Yeah, it hasn't been put into the code yet, but best practice is an isolated area, either outside with a door or something to isolate, or if you do it inside, fire rated would be my best guess, but I mean, my best term, but I wouldn't want to give it a 1 hour, 2 hour, or what have you. That just hasn't been vetted yet.
Yep.
But yeah, anything that would isolate the devices from the population in the buildings for smoke or any other damage. I've seen people that will put them outside under a canopy, but the weather is an issue here in New England, right? It's not San Diego where it's 68 and sunny every day.
Yep.
So you'd have to build that into it and say, okay, well, we're going to enclose it, but you're going to put your bike outside and charge it. That way, if something happens, it's going to go bad. But charging it when it's 5 below zero is leading to one of these causes. It's going to be difficult for that charger to overcome the cold. So you may have to provide some sort of protection so it doesn't get to extreme temperature levels, either high or low. But that's all been yet to be decided. I don't think any of the building codes have come up with anything specific. It's all being left to local flavor. People are coming up with ideas and they have to run it through the AHJ, and the AHJ either works with them and say, oh, let's tweak this a little bit, or they give it a thumbs up and say, that's perfect. Just we'll put it in our pre-plan that's where the bike charging station is. Similar to tow motors and things in warehouses, they have them all lined up along a wall. As long as you know where all those battery chargers are, you know where you can go and shut the power off, and you know where the entrance and exit for the fire service will be to go and battle a fire in that area.
Awesome. Thank you.
Another question on are there some lithium batteries or other batteries outside of lithium that are coming online that are less explosive or less.
They're promising us that the ones that are coming out now, when I say they, it means the researchers and such and the manufacturers, that some of the technologies that are coming out down the road are going to be less volatile. And this goes back probably 15 years or so. I was in Detroit at a EV summit. It was when electric vehicles were just starting to, get traction, pardon the pun. And the chemists and scientists that were working for the manufacturers said, we have multiple chemistries that we're working on. Some of them are much better than what's available currently as far as power and range and things like that, but we haven't made them safe for consumer use yet. So they were still a little volatile, that chemistry. If they can take or find chemistry that is safe, if we could find a way to get electric power out of water and just put a tank of water on the car, it would be perfect. But they're working on it. And I think we'll see it in our lifetime, that it'll be something less volatile, or something that they've found a way to prevent, these incidents from occurring. You can't prevent these batteries from getting damaged in accidents and other things. But and if you make them so bomb-proof, the cars would be so heavy they won't be able to move. So they have to find a happy medium there, where weight distribution and the battery technology, in the EVs, in the micromobility devices, a lot of it is quality of the product and how you use it. Are you abusing it and throwing it down the stairs, or leaving it someplace where it can get beat up on, or are you taking care of it like it was a very high-end automobile when it's a $500 scooter? If you tend to take care of things and they're listed and everything's on the up and up, then chances are you're going to get a good full life expectancy out of that device before you have to trade it in.
Okay. Yeah.
All right. Are there any other questions for Bob this afternoon?
I have one more. This is kind of a bummer way to end it. It's the last question. What are some of the health side effects of exposure to lithium?
Well, most of it is respiratory.
Respiratory.
Because you're breathing that stuff in and it's extremely toxic. It's not something that your body wants or can flush out, like a minor exposure to some smoke while you were, walking through a brush fire or something, where it's just a little exposure and you hurry up and get out of the area. It doesn't take much of these chemicals to get into your system. But they're still doing research. So it's respiratory issues. So it leads to respiratory compromise. My guess is over time, you're going to find cancers and other COPD type respiratory issues as the lungs are battling to fight this off. Skin exposure and things like that, I don't know if it's going to lead to issues in blood or others. The research is ongoing all the time, and the reports are out there, but it's very individual. There's not one big overarching report that says, all right, this is what's going to happen if you're exposed to this. And then the chemistry in the batteries, each of them is slightly different, so you've got slightly different chemicals. For the most part, they're all bad. There's nothing good coming off of these things when they catch fire.
Right. Okay. Thank you.
All right, I'll turn it over back to Michelle then, if there's no other questions.
Awesome. Well, thank you again, everybody, for joining today. We really appreciate it. And if you're not a member of IFMA Boston and you found today's program helpful or valuable, that we hope you would consider joining the chapter, you can reach out to Geo at ifmaboston.org or on our website, ifmaboston.org, for any other information. Thank you guys all, and be on the lookout for new programming coming out soon.
Thank you, Bob.
Thank you, Bob.
Thank you.
All right. Thank you. You all have a great day. We'll be in touch.
You too. Thank you.
All right. Thanks.